Geometry. This is the review sheet for Unit 5 on volume. I want to bring your attention to the focus workbook pages listed at the top. These are pages that are done, problems and pages that are done either because of homework or because of notes. So if you go to look at one of these pages and it's empty, you either didn't do that homework assignment or you might have been absent that day. So make sure that you've done those selected problems before our test. So let's take a look at this review sheet. I'm going to start with number 1. Number 1 is a rectangular pyramid. I know that because the base is a rectangle and it goes up to a point. So what I don't have in this, I have both sides of my base. I have the 15 and the 8, so that's good, but I don't have the height. So I'm going to drop a height down from my point to the center of my rectangular base, and this is my H, and I don't know it. And so I'd like to find it. So I'm going to join my base to this 16.8 slant height that I have here, and when I do, I create a right triangle on the interior of the triangle. It's a little harder on my iPad to make it as visible. But this is a right triangle where one side is H, one side is 6.8, and this other side down here I know is 7.5. I know that because if the entire side of the rectangle is 15, then from the center to the side will be half that. So I can find step 1, H, by using the Pythagorean theorem. A squared plus B squared equals C squared, where in this case, my C is a 16.8 squared. My B and A are the 7.5 and H. It doesn't matter what order I put those in. And so the first thing I'm going to do is square my numbers. So I get H squared plus 7.5 squared is 56.25. And 16.8 squared is 284.24. I'm now going to subtract the 56.25 over to the other side. When I do that, I get H squared by itself, and I have H squared equal to 225.99. So my last step in solving for H is to take the square root of both sides, and that gives me a height of 15.03. So I know that this height from my point down to my rectangular base is 15.03. So now I'm going to do step 2. I'm going to do the volume of this. So the first thing I do is I look at my formula sheet, and the volume of a pyramid is 1/3 big B times H. So the big B, I have to put a formula in for that. So my big B is the area of that rectangular base. And if you go to the top of the formula sheet, the area of a rectangle is length times width. So this then becomes 1/3 of my rectangle's length, 15, times the width, which is 8, times the height of my entire prism, which is 15.03. And it looks like I'm going to get a volume of around 601.2 meters cubed. Remember, we can have slightly different answers if we use slightly different decimals in our problem. So looking at number 2, I have the same situation as number 1. First of all, this is a cone, and it's a cone without the height drawn in. So let me draw that height from the point down perpendicular to the base. This is my H, which I don't know. But this is a right triangle, and so I can set up the Pythagorean theorem to find it. So step 1 is to find my H. So my 42.5 has to be my C squared. So my A and B would be H squared plus my 19 squared equals 42.5 squared. So H squared plus 361 equals, I believe this is around 1,806.25. So again, you could say 0.3 or 0.2. I don't really care about the decimals, but just so you understand, we will get subtly different answers. We're going to subtract 361 from both sides, and I get H squared equals 1,445.25. take the square root of both sides. I'm almost done. And I get h is 38.01. So now I'm going to use that to calculate the volume of my cone. So I go to my formula sheet. The volume of my cone is 1/3 pi r squared h. So volume equals 1/3 pi times my radius squared, which is 19 squared, times my height, which is 3801. And when I square 19 and multiply by 3801 and divide by 3 on my calculator, I get 4,573.87 pi centimeters cubed. If you'd like to multiply by pi as well, then when you get something more like 14,368.24 centimeters cubed. Remember, multiplying by 1/3 is the same thing as dividing by 3, and that's a very simple way to put it into your calculators. So there was a lot of talk about number 3 in class. Number 3, if you turn your paper sideways, it might be easier to see that this is a prism with a triangle base and another triangle base. And this 12 is the height of my prism. So it's like standing on end instead of sitting on a triangle base. So this is a triangular prism. And I'm not missing anything. I have the height of my prism. This is my right angle for my triangular base. So the 5 and the 12 are my base and height. I don't have anything I have to go find. So using my volume sheet for a prism, volume is big B times H. In this case, my big B is the area of a triangle. So at the top of the page, my area of a triangle is 1/2 the triangle's base times the triangle's height. At this point, some students are confused by the two H's. The one in the parentheses, the one with my 1/2 base times height, that's for the red triangle. The other H, I'll make it a capital H, that's the height of my whole prism. So let's plug in our numbers. 1/2 the triangle's base times the triangle's height times the height of the whole prism gives me, when I do my 12 times 5 times 12 times 0.5 for 1/2, 360 centimeters cubed. So let's take a look at number 4. Number 4 is also a triangular prism. There's a blue triangle on the bottom. There's another one on the top. This side is 4 in both places, 4 centimeters. This is a 30-degree angle. So this is also a triangular prism, but this time I don't know one of the sides of my triangle. It's this right here, and I need it. We'll call it the height, but we could also call it B, or we could call it X. The point is that for my triangle's area, I need the 4, and I need whatever that missing side is. So since I'm given the 30 degrees, that tells me that I'm going to use trig to find this H. So step one is to find this side for me. And so let me get a different color here. The H is the side opposite the 30. The 4 centimeters is adjacent. And this blank side over here is the hypotenuse. So I don't know the hypotenuse. I don't need the hypotenuse. So I'm going to use tangent since I'm using opposite and adjacent. So tan of 30, and I think I'm going to go off the page. I'm so sorry. Tan of 30 equals H over 4. I don't even know if I'm squeezing this on. So now I'm going to multiply both sides by 4. I need some room, so let me just come down here. So I get 4 times tangent 30 equals my H. I plug that into my calculator, and I get 2.3 is my H. So now I have my triangle's base and height. I'm ready to put it in my formula. It matches number 3. The prism's formula is big B times H. In this case, my big B is a triangle. So it's 1/2 the triangle's height and base, which is 4, and this 2.3 I found, times the height of the entire prism, which is 6.5. And I multiply 4 times 2.3 times 6.5 in my calculator. And then I multiply by 0.5 for the 1/2. and I get 29.9 centimeters cubed. So let's take a look at the next three problems. So on number 5, it's a sphere, and I need to think about the radius being half of my diameter, because the 32 is the diameter, so my radius is 16. So the last formula on our formula sheet is that volume equals 4/3 pi r cubed. That's commonly the mistake on these problems, is the r cubed. So volume equals 4/3 pi times 16 cubed. So on our calculators, we have to do the 16 cubed first. And then to do 4/3, we're going to multiply by 4, that's the numerator, and we're going to divide by 3, that's the denominator. So we're going to do our 16 cubed times 4 divided by 3. You should get 5,461.3 repeating centimeters cubed. Oh, sorry, that's pi. Let me go back. Pi centimeters cubed, because I haven't multiplied by pi yet. So if you'd like to multiply by pi, this is where you would now get then 17,157.28 centimeters cubed. So let's take a look at number 6. I don't really like where this 10 is. I'm going to put it on this side and just kind of ignore it right there. So this problem is similar to the ones up above. I don't know the height of this oblique cylinder, so I'm going to need to find the height. So in this problem, the 10 is my hypotenuse, and the h is opposite the 40. This is my right angle right here. And so opposite hypotenuse would be sine. It's my part of my SOHCAHTOA. So step 1 for me is to find the height. And to do that, I'm going to do the sine of 40 equals opposite over hypotenuse. Multiply both sides by 10, and I get that my height is equal to approximately 6.4. Now I'm going to use that in my formula for the volume of a cylinder. So step 2 is my volume, and that is volume equals pi times r squared times h. So volume is pi times my radius, which is 5 squared, times this h I found above, which is 6.4. So the first thing I need to do is my 5 squared, which is 25, multiply by 6.4, and then I get 160. So you could write this as 160 pi units cubed, or if you want to multiply by the pi, we're going to get 502.65 units cubed. So this next problem, we did something similar to this on page 620 of our book. This problem, I don't know the height of my cone, nor do I know the radius. So I'm going to use my trig skills to help me find both, because I know this angle is 35, and h is the side opposite, r is my side adjacent, and the hypotenuse is the 10. So step 1 is to find either the height or the radius. So let's go ahead and find the height. So that would be the sine, since it's the opposite side. So sine of 35 equals h over 10. Multiply both sides by 10, and I find that h would be 5.7. So next I'm going to find the radius. Well, the radius is the adjacent side. So adjacent hypotenuse would be the part of SOHCAHTOA. So that would be cosine. So cosine of 35 equals the radius over 10. I'm going to multiply both sides by 10, and I get 10 cosine 35 equals r. And when I plug that into my calculator, I find that my radius is 8.2. So now I've got both the height of my cone and the radius of my cone. I can calculate the volume of my cone. So looking at my formula sheet, the volume of my cone is 1/3 pi r squared h. So I'm going to get 1/3 times pi times my radius of 8.2 times my height of 8.2 squared, I apologize, times my height of 5.7. I would put the 8.2 squared into my calculator first, multiply by 5.7, and then divide by 3. That would give me 127.8 pi inches cubed. If you multiply by pi, then we're getting 401.4 inches cubed for our answer. They're both fantastic. And keep in mind, you might have a slightly different answer on your paper if you didn't use exactly 5.7 or exactly 8.2 for your radius and height. So let's take a look at 8 and 9. So they both have a vertical axis to rotate around. And notice that it's not, on number 8, it's not touching the axis. So this little distance of 1, this empty space, I'm going to have this empty space of 1 on the other side. There's going to be like this empty opening that's got a radius of 1. As this rectangle goes around and around and around, it's 1, 2, 3, 4, 5, 6, 7 total squares. I know the rectangle's 6, but it's 7 total squares away from my axis of rotation. So I'd need to go 7 total squares on the left side, and it doesn't fit. This would be, the first one is in the empty space. This would be 2, 3, 4, 5. You have to keep imagining I'm going out 6, 7 total spaces. 6 for the rectangle, 1 for the empty space. So as this rotates around, it creates this circular shape around the top. And then this corner also creates a circular shape, but it's kind of cut off because my page cuts out on me. So the radius from the line all the way to the edge of this shape is actually 7. And the radius of this little empty area between the axis and where my solid part starts is 1. So to calculate the total volume of this shape, I'm going to find the total volume as if nothing is missing, as if the entire thing is solid. Then I'm going to subtract the part that is missing, the part that is empty in the middle. So this is a cylinder of radius 7 and height of 2. So I know the rectangle only has 6 squares, but there's 1 empty square. So this entire thing, if it was solid, would have a radius of 7. So my total volume would be pi r squared h, or pi times 7 squared times the height of 2. Minus the missing inside part, which is also a cylinder, pi r squared h. It's a cylinder of radius 1 and height of 2. So I'm going to calculate that then. That would be 49 times 2, or 98 pi centimeters cubed for that entire volume if it was solid, minus, this would be 1 squared, or 1 times 2, or 2 pi units cubed of the empty missing space. So the part that's actually solid would be 96 pi units cubed. So number 9 is essentially the same problem. This rectangle is not touching my axis. So as it swings around, this outer corner, which is really 5 squares from the line, will be 2, 3, 4, 5 squares away from the line on the other side. And down here, this corner, which is 5 squares away from the line, I know the rectangle is 3 squares, but it's 5 total squares away, will be 5 squares on the other side. So 1, 2, 3. But I've got this empty part as this rectangle swings around, creating this circular cylindrical shape. This little corner on the inside is swinging around, carving out an empty area that's got a radius of 2. So it'll be 2 units on the other side. And this is my empty space in the middle of this. I commented in class, it's like a toilet paper roll. That's the empty part. That little cylinder on the inside is like the cardboard, and it's the empty space. So again, my total volume is going to be, or my volume is going to be the total volume as if nothing is missing, minus the missing or empty space. They're both cylinders. So for the first one, for the big one, it's 5. It's a distance of 5 away from the line of rotation, the axis of rotation. So it's pi times 5 squared times the height of 1, 2, 3, 4, 5, 6, minus the missing part, which has a radius of 2. So that's pi times 2 squared times the height of 6. When I do that math, I'm getting 150 pi minus 24 pi, and that's going to give me 126 pi units cubed. And if you want to multiply by pi, you of course can multiply by pi at this point. Okay, you guys, so let's take a look at page 2. So for number 10, this problem says, what is the height of a pyramid? Well, it's a pyramid, rectangular pyramid. We'll talk about it in a moment. If the volume is 80 cubic units. So there's a similar problem on page 614. There's some others, but we did a problem on that page similar to this. This is a rectangular pyramid. So, and I'm missing the height. So I'm going to start with the volume formula for a rectangular pyramid. So if I go to my formula sheet, the volume formula for a pyramid is 1/3 big B times H. In this case, my big B is a rectangle. So if I go to the top of my formula sheet, the area of a rectangle is length times width. So if my volume is 80 cubic units, let me put an 80 in for my volume, and my length of my rectangle is 5, the width of my rectangle is 4, and H is what I don't know. I have a couple different ways I can solve this. First of all, I could solve it using, not using my calculator, using fractions. 5 times 4 is 20. 20 times 1/3 would be 20 over 3 times H. So if I'm going to do it this way, you might remember in math class before, they've taught you that if you have a fraction times your variable, you can multiply by the reciprocal to cancel it. The reciprocal is when you flip it. So that'd be like multiplying by 3 over 20. And it works out nicely because the 20s cancel and the 3's cancel. But if I do that on the right side, I also have to multiply by the reciprocal on the left side. And so this is 3 over 20 times 80 over 1. When I multiply fractions, I multiply across the top and I multiply across the bottom. So I'm really getting 3 times 80, which is 240. 240 over 20. And so when I do 240 divided by 20 on my calculator, I get 12. Let's say you don't want to work with fractions. That's okay. At this point right here, you would do 5 times 4 in your calculator, which is 20, and divide by 3. I believe you get like 6.6 repeating. So let's say 6.67 or 6.6 repeating or 6 with a lot of 6s, whatever. So that's what the fraction is equal to. So now I'm going to divide both sides by that number. And I'm not sure off the top of my head what, and I don't have a calculator nearby, what I get when I do 80 divided by 6.67. I doubt if you get exactly 12. You're probably getting 11.99 something, or you might be getting 12.0001 something. You're getting something super close to 12. I think on the review sheet I called it 12-ish. You might be getting a 12, but my point I'm trying to make is if you go to decimals, you're probably going to have decimals in your answer, but your number is going to be really close to what the actual answer is. I'm fine if you say the height is 12.001 or 11.996. I'll be able to see in your work that you use decimals, and it's the same answer. It would be just fine. Okay, so let's take a look at number 11. Number 11 is a cone. And so let me kind of draw it so I can kind of get a picture of what's going on here. It's got a diameter of 6. Well, they're trying to tell me that the radius is 3. The diameter is 6. Then this radius is 3 down here. And then it gives me the volume. Oh, and it wants to know the height. So let me draw the height in. My height goes from the point to my base. It's perpendicular, and that's my height. So right now I have a radius of 3. It's kind of messy. I'll write the 3 down below. I have a radius of 3 and a height of h and a volume of 30 pi. So let's start by writing the volume formula for a cone. It's 1/3 pi r squared h. So let's plug in all the stuff we know. Well, the volume is 30 pi. Okay, great. And the radius is 3. Okay, great. Sorry, I don't know why I wrote a 6. The radius is 3 squared times my height. So at this point, if you want to cancel the pi on both sides, you can. I'm going to wait because I find that kids in class are waiting to do that as well. So this side, you have to do the 3 squared first, and you get 9. 9 divided by 3, this 1/3 in front gives me 3. So what I really have here is 3 times pi times h when I clean that up. So to solve for h, I'm going to divide both sides by 3 pi. And when I do that, I get, because the pi's cancel, I get 30 divided by 3, or I get 10 equals the height. Okay, geometry. So let's find some volume of composite figures. 12a looks a little complicated, but it's actually pretty straightforward. If this side is 9, then this is 9. And that would be the height of this half a cylinder that I have here at the end. The radius of my cylinder would be 4. So what I'm going to do for this one is calculate the volume of the cylinder and divide it by 2. So using my formula sheet, a cylinder is pi r squared h. So I'm going to get my pi times my 4 squared times that height of 9. And I'm getting a volume of 72 pi. And I'm sorry, it's 144 pi. It's 72 when I divide by 2. So I'm getting 144 pi. And then, like I was talking about a minute ago, this is only half of that cylinder. So let's divide that by 2. And I get 72 pi. Now, the other two shapes are not going to have a pi in their answer. So I'm going to go ahead and multiply by pi right now and get 226.2 yards cubed for the volume of my half cylinder, because I'm going to need that to add to the others. So let's take a look at this rectangular prism in the middle. It has a height of 8, I got that from the other side, a width of 9, and a length of 8 and a width of 9 and a height of 23. It's like laying on its side if you want to think about it that way. So this is a rectangular prism. So my volume is big B times H, where my base is a rectangle, the 8 by 9 rectangle. And so my base is length times width times height, or I get 8 times 9 times 23, or my volume of this middle center piece is 1,656. So on the end here, this is a pyramid. It's a rectangular pyramid. My base is a rectangle that's 8 by 9, and my height is 11. So my formula for a pyramid for volume is 1/3 big B times my height. And my big B is a rectangle, so its area is length times width. So I'm going to plug in my numbers. This is 8 times 9 times 11. And when I multiply those and divide by 3, I get 264 yards cubed. So I'm now going to add up my 264, my 1,656, and my green 226.2 yards cubed, and I'm going to get a total of 2,146.2 yards cubed. So now let's look at 12B. This is a cone on top of half a sphere. So this problem, I don't know the cone's height. So my step 1 will be to find this cone's height. So I'm going to use the Pythagorean theorem. The h and the 5 are my legs. The 13 is my hypotenuse. So I'm going to have h squared plus 5 squared equals 13 squared. h squared plus 25 equals 169. Subtract the 25, h squared equals 144. Take the square root of both sides, and h equals 12. So I know my height is 12. So I can calculate the volume of that cone now. So step 2 will be the volume of my cone. The volume of my cone is equal to 1/3 big B times h. So my volume is 1/3 pi r squared times h. So it's 1/3 pi times my radius of 5 squared times my height of 12. And when you multiply those together, you get 100. Multiply those together and divide by 3, you get 100 pi centimeters cubed. Or if you want to put it in decimal, you would get 314.16 centimeters cubed. So that would be my cone. So now let me grab a different color. I'm going to do my sphere. So first of all, I'm going to calculate the volume of an entire sphere, and I'm just going to divide that by 2. So my formula for the volume of a sphere is 4/3 pi r cubed. So when I put my 5 in, when I'm doing this problem on the calculator, the first thing I'm going to do is 5 cubed. You should get 125. Then I'm going to multiply by 4, and then I'm going to divide by 3. You should get approximately 166.6 repeating pi centimeters cubed. I'm going to divide that in half because remember, this is only, let me get a different color, this is only half of it. So when I divide it in half, I actually get the volume of half of it to be 83.3 repeating pi centimeters cubed. Or if you multiply by pi, it is 261.8 centimeters cubed. So at this point, it's time for me to add up my half a sphere and my cone. And it doesn't matter whether you use the decimals or the pi. So I'm going to add the 833.3 pi to the 100 pi. I'm going to add the 261.8 to the 314.16. Keeping in mind it's totally fine to have some different decimal places than me. So my total volume, like the volume of the whole thing, you're either going to get 183.3 repeating pi centimeters cubed, or you're going to get 575.96 centimeters cubed if you keep it in decimal form. So let's take a look at 13 and 14. So 13 is an example of a two-step problem. By the way, these are on page 573 of our book. These are really the identical problems. I just changed the numbers. So let's take a look at them. A board game manufacturer wraps its box in plastic. Most games come in a popular, or the most popular game comes in a box that's 9 centimeters tall. So you guys, this is the original height. And then it uses 1,408 square centimeters. So this is the original area. And I know that for two reasons. One, it says square centimeters for the units. So square is area. But two, the plastic wrap around your game, like if you buy a game, that plastic wrap is really the surface. It's not the volume, it's the surface. It's covering the surfaces, it's covering all the sides. So it's a surface area. So that's my original area. So then it makes a smaller box that has the travel version, that has an area. So this is the smaller box after it's been made smaller. So this is the image area of 198 square centimeters of plastic wrap. And it wants to know how tall the travel box is. So this is the image height. So first of all, I'm going to use my areas, since I know both of them, to find my K. Step 1 is to solve for K. So to solve for K, I'm going to plug in my image area, 198, is equal to K squared times my original area, which is 1,408. So now I need to solve this equation for K. So I'm going to divide both sides by 1,408. When I do that, I get K squared equals 0.140625. And I'm not done because I need k. So I'm going to take the square root of both sides. And I get that k equals 0.375. So this is almost a third as big as the original. It's gotten smaller, and it's smaller by my scale factor of 0.375. So to find the image height, remember the height is a length. So image height, image width, that's going to be equal to the scale factor, so just k times the original height. And so my image height, which I'm trying to find, this is my step 2 of my 2-step problem, is going to be my 0.375 times my original height of 9, and I'm going to get 3.375 centimeters since it's just a height, nothing squared or cubed. So let's take a look at number 4. Number 4 says a cone has a surface area of 360 pi inches squared. So this is my original area, and a volume of 600 pi inches cubed. So this is my original volume. And the cone's dilated, and the surface area, it gets bigger. So this is dilated bigger. The new area, so the image area, is the 2,250 pi. And it wants to know what the image volume is. Again, it doesn't tell me k, so I know this is a 2-step problem. So step 1 is to solve for k. And I have to use the two things that I know both of is the area. So I'm going to use my area equation. So the image area, 2250, equals k squared times the original area, which is 360 pi. And I'm going to divide both sides by 360 so I can solve for k. And when I do that, I'm sorry, can you make a correction? My 2,250 should have a pi with it. And I need that pi because now these cancel, my pi's cancel, and I do 2,250 divided by 360, and I get 6.25 equals k squared. I take the square root of both sides, and I get that k equals 2.5. So my cone is 2.5 times bigger than the original. So now it wants to know what's my new volume. So remember, the volume equation is the image volume is equal to my scale factor cubed. So that's going to be my 2.5 cubed times the original volume, which is 600 pi. So I've got to do the 2.5 cubed first, and then I'm going to multiply by 600. I get 9,375 pi inches cubed. If you want to multiply by pi and get that answer, that's fine too. Okay, I hope this video was helpful for you, and I will see you either in office hours or in class. Thanks.